Hello and welcome to the lesson on converting between different types of fractions. So this is kind of just a review of stuff that you've probably covered in Year 7 possibly. So converting improper fractions to a mixed number. So an improper fraction is where the numerator, the number on the top of the fraction, is bigger than the denominator. So these are three examples of improper fractions because see their numerators, their top numbers, are bigger than their denominators, which are the bottom numbers. Like 9 is bigger than 5, 22 is bigger than 7, and 19 is bigger than 2, and so on. So we need to practice converting them. So what you need to do is just think how many fractions mean divide. So you've got to think how many times does 5 go into 9? So 5 divides into 9, would you agree, once? And how many remainder? So 5 goes into 9 once with a remainder of 4. Sorry. So remainder of 4. I'll just do that again. So once goes in there once. Sorry. So divides in there once. The remainder of 4 fifths. See, the denominator hasn't changed. So 1 and 4 fifths. 7. How many times does 7 go into 22? So 7 divides into 21 3 times. So it would end up being 3 times. And how many remainder? Because 3 times 7 is 21, so 1/7 remainder. See, the denominator didn't change. So 1 and 4 fifths, 3 and 1/7. Then 19 over 2, how many times does 2 divide into 19? That's right, 2 divides into 19, 9 times. How many remainder from 9 times 2 is 18, so 1/2 remaining. Sorry about that, I'm trying to write with this stylus on a pad, and that's kind of difficult. Okay, so 1 and 4 fifths, 3 and 1/7, 9.5. Whereas if we're converting, these are examples of mixed numbers because it's a mixture of a whole number and a fraction, whereas the top are improper fractions. So what if we had to do the reverse? What if we had to convert from a mixed number to an improper fraction? So looking at this example here, so if it was 1 and 4 fifths, you'd think, okay, what's 1 times 5? 5 plus 4 would give 9 fifths. So let's do the same. Let's apply the same method here. Converting a mixed number to an improper fraction. So you're trying to think what's 1 times 5? 1 times 5 is 5 plus 3 all over 5 still. So that's kind of the thinking, the working that's gone on behind there. So 1 times 5 plus 3. So that would give us 5 plus 3 is 8 fifths, which makes sense because 5 goes into 8 once with 3 remaining. Next one, you think take the whole number and multiply it by the denominator. So the whole number is 2. 2 times 3 is 6. And then add the remainder, the 2/3. 2 times 3 is 6. 6 plus 2 is 8. So 8 again, but this time the denominator is 3, because it's just 8/3. 2 times 3 is 6. 6 plus 2 is 8. And the last one, we've got whole number is 3. 3 times 7. 3 times 7 is 21. Plus 1 would give you 22/7. So weirdly enough, that happened to give us the one that we had above. We'll see 22/7 is one of the above ones. So see, they're all improper fractions because their numerators are larger than their denominators. Again, sorry for the writing because I'm experimenting with using a touchpad instead of the smartboard. Simplifying fractions. Simplifying fractions is nice and easy. So you just kind of like, you try to simplify. 12 over 16 can be simplified because there's a common factor. You think, what can 12 and 16 both be divided by? That's right, they can both be divided by 2. So you might want to start by dividing by 2. So divide by 2 would give you 6 over 8. Can that fraction be simplified any further? And yes, it can, because the numerator and denominator can both be divided by 2. So doing that, we would get 3/4. And then you just have to think, does that simplify any further? And no, it doesn't. Simplifying fractions. So next one along, we've got 36 over 21. So 36 and 21, they're not both even numbers, so don't bother dividing the numerator and denominator by 2. But what can they both be multiplied by? Sorry, divided by. They can both be divided by 3. because 3 plus 6 is 9, that's a multiple of 3, and 2 plus 1 is 3, that's a multiple of 3. That's how you can test if it's divisible by 3. So what's 36 divided by 3? That's right, it's 12. What's 21 divided by 3? That's right, it's 7. So 12 over 7, can that simplify any further? No, it can't. You do not have to turn it into a mixed number. So you can leave it as an improper fraction. So this is totally fine as an answer, 12 sevenths, because it's simplified. If it was a mixed number, would you agree it would be 1 and 5 sevenths? 18 over 45, they're not both, they're not both even numbers, so you can't divide by 2. 18 and 45. 45 is a multiple of 5, but 18 is not, so we can't divide by 5. They tend to be the most obvious ones. So then look for 3. 18, is it divisible by 3? If you're not sure, what's 1 plus 8? It's 9, and 9 is a multiple of 3. What's 4 plus 5? It's 9. It's a multiple of 3. So these can be divided by 3. So divide, whatever you divide the top by, divide the bottom by as well. So 18 divided by 3 would give you 6. And what's 45 divided by 3? Have a think. It is 15. And then you just have to think, can I divide this? Can I simplify this anymore? Yes, I can, because 6 is a multiple of 3. Sorry, 6 is a multiple of 3, and so is 15. So we can take it further and divide the numerator and denominator by 3, which would give us 2 over 5. So 2/5 is our final answer. So that's what you always have to do. You always have to think, can I simplify it further? If I was being asked to say 3/4, the one on the left, if I was being asked, describe this as over denominator to 16, because you might see that. So if you want to write this as a fraction over 16 instead, you think, what do I need to times the denominator by to make it 16? I need to times it by 4, so I'd have to times the top by 4. So that times 4 is 16, 3 times 4 is 12. If I wanted to write it as a fraction with denominator 20, I'd have to think, what do I need to times 4 by to make the denominator 20? I'd need to times it by 5. So then I should multiply the numerator by the same amount. 3 by 5 is 15, so it would be 15 over 20. Just because you might get some questions like that. And that's the end of the lesson. Thank you very much.